In this video, I will do examples involving properties of tangent lines and circles. So in a previous video, we looked at these theorems about tangent lines. So I'll take these and show some examples involving them. Alright, I'll start with this one right here. Okay. Over here, we need to find the far arc. We don't know the near arc, but we know the angle. From our previous notes, we figured out that angle plus near arc equals 180 degrees. So over here, we're trying to find near arc. 70 plus x equals 180. So this x. Subtract 70 both sides. X equals 110 degrees. Now that we have a near arc, we can find our far arc. Using one of our formulas states that angle equals far arc minus near arc divided by 2. So plugging this into my formula, I have 70 equals, let's go ahead and call this y minus near arc, which we know is 110, divided by 2. In one of our formulas over here, we mentioned that dividing by 2 over on this side is the same as having 2 on the multiplying by 2 on the other side. And really mathematically you get that by multiplying both sides by 2. So we have 2 times 70 equals y minus 110. Continuing on, 140 equals y minus 110. Add 110 to both sides, and we get y equals 250 degrees. So this is 250. Next example. Again, this is a case where angle plus near arc equals 180. So let's call this x. Angle plus near arc equals 180. Subtract 123 on both sides. You get 57. So that's 57. Next, number 10. Assume that lines which appear to be tangent are tangent. We are solving for the question mark. So this uses this property that when we have a tangent line, radius is perpendicular to tangent line. So here's my radius, down here's my tangent line, which means this is a right angle, which lets me use Pythagorean theorem. So let me move my paper sideways. There's your right triangle. Now let's find the hypotenuse, h. Or in Pythagorean theorem, hypotenuse is c. So let's use a squared plus b squared equals c squared. So use your hypotenuse. So we have 14 squared plus 10.5 squared equals c squared. Working on that. 14 squared plus 10.5 squared Then we can square root that number. Sorry, 14 squared plus 10.5 squared. Then we can square root that number, 17.5. C equals 17.5. Right here is our hypotenuse, which means over here, this entire segment is 17.5. But I want to find just the question mark part. Just this bottom part right here. How can we do that? Because all I know is the entire segment, 17.5. But take a look at this. That line's a radius, which is 10.5. This line over here is also a radius, which means this segment over here is also 10.5. So now what we have is, this full line is 17.5, the top portion is 10.5. To get the bottom portion, we can just subtract. 17.5 minus 10.5 equals 7. There's my answer. Next up, number 12. Still working on the same concepts here. We have a tangent line. Because we have a tangent line, this is a right angle. So now, I want to find this entire part. And there's your right triangle, so we can use Pythagorean theorem. A squared plus b squared equals c squared. 8.7 squared plus 11.6 squared equals c squared. Go ahead and solve for that. C equals 14.5. Which is this entire segment right here. And that's my answer. Notice, right here I stopped at C equals. Back here, after you found C, we continued. Because down here, it only asks for this bottom part. Whereas over here, it asks for the entire hypotenuse, which is what C is. Right, last one I'll work on, number 18. Number 18 uses this concept right here, that when we have two tangent lines that intersect at an exterior point, these two tangent lines have to be congruent. So, number 18, here we go. So using that idea, I see right here, whoops, let me be on the screen. I see right here is 7.9, which means this side, it's congruent. This is also 7.9. Now let's find this part. This entire right side is 14. The red part 7.9. So what we can do is 14 minus 7.9 to get me 6.1. So this right here 6.1, 6.1 and 7.9 together added 14. So if this side 6.1, that means this side up here is also 6.1. They're congruent. Next up, I want to find this part right here. We can do that by doing 16.1 minus 6.1 equals 10. So this part is 10, which means over here is also 10. And lastly, I want to find this bottom part. Again, entire left side is 14.9 minus the top part in green, minus 10, equals 4.9 on that side, which means this part's congruent, also 4.9. Now this question can ask for perimeter. So let's write that down. Find perimeter. Perimeter would be adding this part plus this part to make my entire bottom side. This part plus this part makes my right side. This part plus this part is my entire top side. And finally, this part with this part makes my entire left side. So let's add all those numbers up. Plus 4.9 plus 7.9 plus 7.9 plus 6.1 plus 6.1 plus 10 plus 10 to get perimeter equals 57.8. Another way you could have done this is, instead of using 6.1 plus 7.9, you can use 14 instead, because you know this whole side is already 14. I just wanted to show you that you can either use these two numbers or use that one number, but don't use both because you will end up doubling your sides. Alright, so here you have different examples of properties involving tangent lines. Number 2, number 6, number 10, number 12, and number 18.